In this video, I'll talk about an elevator problem like physics problem. So a girl who weighs 500 Newton on a ground level steps up into an elevator and she reads now 530 Newton. Is this information enough, sufficient to tell the direction of the elevator motion? Or in other words, what it's asking is, would you be able to tell whether the elevator is going up or it is going down? So again, the question is, a 500 Newton girl on a ground level, or when the elevator is not moving, steps up in an elevator and the reading is now 530 Newton. Is this information sufficient to tell the direction of the elevator? Well, the short answer is no, it is not sufficient. So now let's dig into a detailed explanation of this one. How? So the weight of the girl is 500 Newton. From this information, we can find out the mass. The mass is m times g, and this mass is 51 kilogram. And the mass does not change whether you are in an elevator or you are on moon, Jupiter. It remains the same. The weight might change. So if the elevator is going up, let's say for example in this particular situation here, if the elevator is going up, we're going to apply the Newton's second law of motion. What does the Newton's second law of motion tell you is F is equal to ma. And remember, this is the net force. This is the net force. Okay, that means all the forces in the direction of motion has to be considered. All the forces. So in this case, when the elevator is moving up, all the total forces is T, which is vertically upward, minus mg. The mg is downward. So that's the net force times m times xa, which is the acceleration. So if we solve for t, what we get is mg plus a. So the first impression that you might get as the reading is going up and the reading has increased, the elevator must be going up. But that's the catch there. Even the elevator is going up, the one time the A can be positive or can be negative. What does it mean? This means that even if the elevator is going up, the one time it speeds up from rest to a certain velocity, and when it wants to stop, it slows down. So the acceleration is positive one time, and when it tries to come to a stop, it deaccelerates. That means the A becomes negative. So the tension one time rises and then one time falls. Now let's take a look at what happens if the elevator is going down. When the elevator is going down, then the Newton's second law of motion tells you T is equal to m minus GA. And again, A can be positive or it can be negative even if it is going down. So we cannot come to any conclusion that just by the information that the tension or the reading has increased, we cannot tell whether the elevator is going up or going down. Now let me convince you through a simulation. This is a wonderful simulation. So here it is. So a person is an elevator and her weight onto a ground level or in an elevator when it is not moving is 1000 Newton. Okay, so I'm pressing let's say we go to the second floor, and here we need to keep an eye onto this one, how the velocity changes and how the normal force and this weight changes. So let's take a look. Now it starts going up. You see it is going up now. Now it has reached to the second floor. Okay, so what is happening here? The velocity has increased. That means the acceleration is positive, it is going positive, and then the velocity stays constant, and then it has to stop onto the second floor, so it starts decreasing now. So here the acceleration is positive, the acceleration is negative. So the weight changing. Now just take a look onto this one. Let me start again. Okay, let me restart this one. Okay, one more time. So we'll go, I'll just make this acceleration everything high. So this one is 1000 Newton, and just keep an eye onto this one. So this one is now 1000 Newton, from now 900 Newton. So it has changed now, again 1000 Newton. So it has gone one time 1100 Newton and then 900 Newton. So even while it is going up, the reading goes up and then goes down again and comes back to the normal, of course. So now if it is going down, what happens? Let's see. Again, the 1000 Newton. So again, 900 Newton, 1000 Newton, 1100 Newton. So the reading has again gone down and then gone up again, because it starts decreasing, or the acceleration is negative here and the acceleration is positive here. So the conclusion is, if just by reading the tension or the apparent weight has increased, we cannot tell the direction of the elevator. So that's it. Again, if you have any questions or any comments, write down in the comment section below, and do not forget to share, like, share and subscribe the channel. Thank you very much.